All right, question number 3. The position s in centimeters, so there's our displacement, of a particle at time t in seconds is given by, and then here's our displacement function, 1/3 t cubed minus 6t squared plus 7. When is the particle slowing down? Okay, slowing down this is more of a scalar issue. Okay, this is not velocity going negative, because you can be speeding up and your velocity be negative. Just think of something dropping towards the earth. Okay, so what we need here is we need to figure out the scenario where the velocity and the acceleration are in opposite directions. Okay, so as long as your velocity and your acceleration are working in opposite directions, you will slow down. And again, the best example of this is just think about what happens when you throw something upward. Okay, its velocity is positive, but its acceleration is negative. It's wanting to come back down. The whole time the thing is on the upward journey, it's slowing down. Now in this case right here, the velocity, when we take a look at our function here, take our derivative, is going to be t squared minus 12t. And then we take the derivative again to get our acceleration, we get 2t minus 12. So I want to multiply these two together. Now remember, this doesn't have any physical significance to multiply those together. This is just going to give us an idea of when it's slowing down. I'll factor this out and I get t times t minus 12 times 2 times t minus 6. And that's when this thing is less than 0. Now, I want to go back and utilize information that you already have. You already know that when you multiply a quadratic by a linear, that the result is cubic. And right here, when I factor it, I get three different factors with with t in it. It's a positive cubic, so that means the general motion of the cubic is going to be upwards. Okay, so it's going to look like this, and it's going to hit the x-axis, or in this case the t-axis, at the 3 spots where this could go to 0. So at 0, 6, and 12. So then when is this thing slowing down? Well, when is this expression here less than 0? Well, if I graph it like this, I can tell by looking at it. Now, it doesn't make sense to talk about anything less than 0, so this part here that's negative is really not the issue. It's this part right here. Okay, and so my answer is going to be between 6 and 12 seconds, or if I want to write it using interval notation, 6 and 12. Now notice I'm not including 6 and 12 because that would indicate when the thing has stopped, and or has 0 acceleration, which would again mean it's slowing down, has stopped, and we don't want to include those.